Where do formulas come from? I think students often have the perception that formulas were dreamed up by somebody to do a particular thing, and they're not dreamed up by anybody. Anybody could be coming up with most of the formulas that you use in math. What we're going to do right here is derive the quadratic formula by completing the square of the standard form of the quadratic equation. So, to get started, let us start by writing out the standard form of the quadratic equation. The standard form is y equals ax squared plus bx plus c. What we're going to try to do is get x alone. And we're going to try to get x alone by completing the square. So if we're going to complete the square, the steps are all the same, except now we're doing our steps with a, b, and c instead of with integers like 1, 2, and 3. First thing to do is to set it equal to 0. The next thing to do is to move c, and I'm just going to switch my 0 to the other side because that's how I'm accustomed to working. Okay, now we need to divide through by a, because a must be equal to 1 when we complete the square. A over a is definitely 1. I prefer to write this fraction in this way, b over a times x. You can also write b times x over a. Those are equivalent, but just me, in my notational style, I prefer to write b over a times the quantity x. As we proceed here, we're going to be switching kind of from working on the left side to working on the right side. You don't need to do both sides at once. I'm going to start by working on the left side, and we're going to complete the square. We are going to add the value that forces this into being a perfect square quadratic, and that value is the same as it's always been, b over 2 squared. So the thing that gets confusing here is that b is this quantity b over a. That's equal to like b right now in our quadratic equation. So we're going to take that, we're going to divide it by 2, and we're going to square it, we're going to add it to both sides of the equation. And I am going to sort of strategically choose to write 1/2 ba squared. I like to think about it like that. 1/2 ba is the same thing as b over 2a, but just in my brain it's easier for me to think about the c term as being 1/2 b over a. We're adding that to both sides. And now we're going to continue by factoring and expressing the left side as a binomial squared. So I am deliberately not doing the squaring. And that's because when you factor a perfect square quadratic, what you're doing is you're taking the square root of c, and that's what you're going to put into your binomial. So the square root here of 1/2 b over a squared is just 1/2 b over a. So we're going to get x plus 1/2 b over a, all squared. Now, if you're a little confused by this, I actually think this is the most confusing step in the process of deriving the quadratic formula by completing the square. Let's think about FOIL just a little bit. This expression is equal to x plus b over 2a times x plus b over 2a. So if we do the multiplication here, b over 2a times b over 2a is b over 2a squared. Okay, well that's the same. Good. And then 1/2 b over a plus 1/2 b over a is equal to a whole b over a. And that's what we've got right there. So I think that this factoring step is actually the hardest step to see, and it's because, and that's why I like to write it as 1/2 b over a, because I think it's very easy to think about 1/2 of b over a plus 1/2 of b over a equals 1 whole b over a. And 1/2 b over a times 1/2 b over a is 1/2 b over a squared. So that's why I deliberately did not do the squaring of the c term in the line above. And I think it's just easier to think about it like that. Okay. So what we're going to do is we're going to continue by writing x plus b over 2a squared. And now we're going to do a little work on the right side. The left side's done for the time being. So over here, I am going to do the squaring. I have b over 2a squared, and I'm just going to square the numerator and square the denominator. Negative c over a plus b squared over 4a squared. And if I'm trying to get x alone, I really need to be able to take the square root of the left side, but it's not so convenient to take the square root of the right side right now. And remember, whatever I do to the left, I got to do to the right. So the thing to do is to find common denominators. If I can find common denominators, then I can add those two fractions together. And if I can add those two fractions together and express it as a single fraction, it's pretty easy to take the square root of. So to get common denominators, I need to multiply that negative c over a by 4a over 4a. That's a form of 1. So if I do that, I don't change the value at all of my expression. I just am sort of massaging it into an easier to work with form. So let's do that. 4a times over 4a times the quantity negative c over a plus b squared over 4a squared. Negative 4ac over 4a squared plus b squared minus 4a squared. And I haven't written it in a bit, but this is still equal to x plus b over 2a squared, x plus b over 2a squared. Okay, now that I have the common denominators on the right, I can add it together. And I'm going to negative 4ac plus b squared over 4a squared times the quantity x plus b over 2a squared. On the right side now, I'm going to just flip the order of the numerator, and that's just partially because I know what I'm going for. I know what the quadratic formula is, so I'm going to put it into that correct form, but it's also convention. The term with the highest exponent should be listed first in the sum. So b squared minus 4ac over 4a squared is equal to x plus b over 2a. And now I can take the square roots of both sides. And it's not tough anymore because my right side equation is a single fraction. So if I take the square root of the left, I get x plus b over 2a equals, and now I'm going to get a plus or minus sign over here, and I have a square root of b squared minus 4ac, and I can't really do anything with that, but my denominator I can do stuff with. I can break it up, and I write root 4a squared. And since 4 is a perfect square and a squared is a perfect square, 4a squared is a perfect square, and therefore the square root of it is just 2a. Cool, we are getting really close now, and if you already know what the quadratic formula is, you should basically see it being right in front of us. I can subtract my b over 2a, and x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. And since I've got common denominators, I can combine this as a single fraction and write negative b plus or minus the square root of b squared minus 4ac all over 2a. And I now have successfully isolated x, and in doing so, I have derived the quadratic formula. This is a formula that you can use to find the value of x when y is equal to 0. You use it in the same way you would use completing the square or solving a quadratic by factoring, except that the formula is way more convenient when it can't be factored and it looks like completing the square will be a really big pain. In the next video, I'm going to do an example of using the quadratic formula to solve an equation, and the value of x, the solutions, are going to be decimal values. So the quadratic equation is definitely going to be useful. I hope this video is explanatory. Feel free to watch it a couple of times. It's no single step here is too hard for you to think about. We're bringing together a ton of different math from the year and from previous years of learning. We have this completing the square idea. We have some exponent rules. We have some radical rules. We are finding common denominators. There are all sorts of different math ideas from the last 2-3 years of your education built into this one derivation. It is worth taking time to watch and understand how you go from each step. Okay, see you around.